So, this is our group members. The first member is Asha Alisa. The second member is Nur Izzati. The third member, which is me, Nurin Adrana. And the last member is Alia Ayuni. Have you ever heard about calorimeter? What is a calorimeter and its significance in our lives? Today, let us dive into the world of measurement, particularly in the realm of heat release and absorption. Let me introduce you to a fantastic tool, not unlike a detective of the scientific world, which is the calorimeter. A calorimeter is a device used to measure the heat release or absorbed in a chemical or physical process. The basic principle behind a calorimeter is to isolate the reaction or process of interest and measure the temperature change it causes in a known mass of water or another substance with a known heat capacity. Just as the detective unravels the mystery behind a crime paper, our calorimeter helps us decipher the amount of heat absorbed and altogether released during physical or chemical changes. Picture this. A chemical reaction taking place or a piece of ice melting. How much heat is involved? This is where our calorimeter springs into action, explicitly designed to measure these thermal exchanges. So, next time when you encounter a curious scientific fact involving heat measurements, remember this scientific detective, which is the calorimeter. It helps us to comprehend the energy involved in these processes and expands our understanding of the world around us.
Calorimeters are used to measure the volume and heat produced during a certain time interval. Calorimeters are devices that monitor heat transfer during a chemical or physical process. They are widely used in a variety of fields, such as in food calorimetry. Calorimeters are used to measure the caloric content of food items. This is essential for nutrition labeling and dietary plan. By burning a sample of food in a calorimeter, researchers can determine the energy content in terms of calories or joule. Next, the use of calorimeter is important for several reasons across various scientific, industrial, and educational applications. Here are some of the main reasons why calorimeters are considered important. First, nutritional information. In the food industry, calorimeters are used to determine the caloric contents of food items. This information is crucial for nutritional labeling and dietary planning. Consumers and regulators rely on accurate caloric information to make informed choices about their diet. Next, research and development. In both academia and industry, calorimeters are indispensable tools for researchers developing new materials, studying reactions, or optimizing processes. They provide quantitative data that help scientists and engineers make informed decisions in their work.
A calorimeter is a device that is used to measure the amount of heat associated with chemical or physical processes. There are many different types of calorimeter, which are adiabatic calorimeter, reaction calorimeter, bomb calorimeter, constant pressure calorimeter, and differential scanning calorimeter (DSC). Firstly, adiabatic calorimeter. What is that, you may ask? In principle, an adiabatic calorimeter, which heat is confined to the calorimeter usually by surrounding it with an adiabatic shield. In practice, temperature gradients in the calorimeter and shield cause a net heat exchange during the experiment. Next, a reaction calorimeter. A reaction calorimeter is a tool used by scientists in chemical and pharmaceutical development to measure the amount of energy released or absorbed by a chemical or physical reaction. It typically consists of a stirred tank, reactor of variable size, in which the temperature of the reaction mass is monitored and controlled accurately. Let's move on to bomb calorimeter. Bomb calorimeter is an apparatus used for measuring heats of combustion. The reaction takes place in a closed space known as the calorimeter proper, in controlled thermal contact with its surrounding. The calorimeter usually consists of a metal can with a tightly fitting lid containing water, stirred continually in which the bomb itself is situated. Next, constant pressure calorimeter. Constant pressure calorimeter is used to measure the change in enthalpy for a physical or chemical process. In this technique, a process is carried out in solution in a coffee cup calorimeter. It is an inexpensive device composed of two styrofoam cups. The amount of heat transferred in the process can be calculated from the mass, specific heat, and temperature change of the solution. So, lastly, differential scanning calorimeter. The differential scanning calorimetry (DSC) is a main technique for thermal analysis. DSC detects endothermic and exothermic transition like the determination of transformation temperatures and enthalpy of solid and liquid as a function of temperature. In contrast to classic calorimetry, where a sample is put into an isolated chamber to monitor its heat uptake and release.
Next, I will share about the application of calorimeter in the industry. How is calorimeter used in industry? I will share about the two applications of calorimeter, which is in food industry and also the pharmaceutical industry. So we go to the first one is food industry. In the food industry, calorimeter is used to determination of caloric content. Calorimeters are employed to measure the caloric content of food products. This information is essential of nutritional labeling, quality control, and the development of healthier food options. Okay, for the pharmaceutical industry, it's used in drug development. Calorimeter is used in the pharmaceutical industry to study the heat effects of drug receptor interactions, providing insight into the thermodynamics of drug binding. This information aids in drug development and formulation. In conclusion, calorimeters play a crucial role in various aspects of life, providing valuable insights into the energy content of substance and aiding in diverse applications. The application and usage of calorimeters extend across different fields, including chemistry, biology, food science, and also environmental science.